Want to be an efficient Linux administrator? Then you have to know the tail command. Today, we're putting it under the microscope. And stick around till the end, I'll show you how to use tail to even spot corruption on zip files. This is the basic syntax of the tail command. The options and the file arguments shown in square brackets are optional, and the 3 dots mean that the previous item can be repeated. Let's start simple and print the last 10 lines of a file. By default, the tail command shows the last 10 lines. If we want more than that, we use the n option, followed by the number of lines we want. And if we add a plus sign in front of the number, tail will start printing from that line number instead. Now, one of the most useful options is F for follow. This keeps the process running, and every time a new line is added, we see it live in the output. To demonstrate this, I've created a script called generate logs. This script writes 1 line every second and includes a timestamp. We'll run the script in the background using the ampersand so we can tail the log file at the same time. And as you can see, new lines appear instantly in real time. Another powerful use of F is with the PID option. By specifying a process ID, tail will keep running only while that process is alive. For this example, I created another script that runs for 10 seconds. Once the script stops, tail stops automatically as well. Here we use the process ID of the running script. As you can see here, tail stopped together with the process ID 29045. Next, let's see a very important use case. Sometimes the file you're monitoring gets rotated or moved. Log rotation is very common on Linux systems. To handle this correctly, we use capital F. This option tells tail to keep retrying the file name even if it disappears for a moment. I've created a cron job that simulates log rotation by renaming the file every minute. Without capital F, we would lose new entries when the file rotates. But with capital F, tail reconnects automatically and continues showing new log lines from the new file. Let's wait for the new minute to start so the cron job can rotate the file. That's the real difference. Lowercase f follows the file descriptor, while capital F follows the file name and retries. With the tail command, we can also limit the output of another Linux command. For example here, instead of displaying all the files inside directory 1, we're showing only the 5 most recently modified files by piping the output of the ls command to the tail command. Now let's look at a scenario that can actually help you detect corrupted data. In this example, we're going to check the integrity of a zip file. At the very end of every zip file, there's a specific hexadecimal signature called the end of central directory. With the help of the C option, we can output the last defined bytes of a file instead of lines. And combined with the hex dump command, we can convert these bytes to hexadecimal values. If that signature is missing or damaged, the system can't understand where the zip file ends. Let's take a look. As you can see here, both of these zip files contain that hexadecimal signature. Now let's look at a corrupted zip file where that signature has been altered. As we notice here, the 50 have been altered to 40. When we try to unzip it, it fails. The error tells us exactly why. The expected end of central directory signature was not found. This is a simple, straightforward example, but it shows the big picture. Sometimes a quick check at the end of a file can immediately reveal corrupted data. Did you enjoy the video? Let me know in the comments, it really means a lot to me. And if you found it useful, don't forget to hit the like button and subscribe so you don't miss the next videos. Thanks for watching.